Hello, Professor Sargent here with you again. We're going to take a look at multiplication and division of fractions. Here we go. The primary concentration here is going to be on dividing fractions because that's what gave students the most difficulty on the homework problems from a previous semester. So why does the way we divide fractions, why does that work? All right, I'm going to be showing two methods here. The first one, I learned it as invert and multiply, where you take this second fraction, you flip it over and multiply. In other words, you're multiplying the first fraction by the reciprocal, also known as the multiplicative inverse of the second. But these are just ways of remembering the name, remembering the process, and it's not explaining why it works. So here's showing the answer. You'll flip over just a second and then multiply straight across the numerators to get the numerator of your answer, and similarly for your denominators, and reducing if possible. But what we want to know is, why is that valid? So one way of explaining this is that every division question has a related multiplication question. So whatever the answer to that is, let's call it X for the time being. If we multiply both sides by the reciprocal of the second one, so C over D, here's what we get. Oops. Let's change that, make that visible. All right. So multiplied on the left side, but also on the right side here, the C over D and D over C, they're multiplicative inverses of each other. When we multiply them together, we get the multiplicative identity 1, meaning that when we multiply something by 1, it doesn't change that other something. So that is the desired quotient. Dividing A over B by C over D, we do get A over B times D over C, i.e. A times B all in the numerator over B times C in the denominator, and again reducing if possible. Now the second method, if you get a common denominator, or better yet, the least common denominator of the two fractions you're dividing, then you can divide the numerator straight across, left to right. Do the same for the denominators, divide straight across, left to right. And since you have to have a least common denominator there, when you do that along the denominators, you're going to be getting 1. Since that's not 0, then it's legal to do that division, and we're getting the same answer. So I multiply top and bottom of A over B by D, and top and bottom of C over D by B, so that I have the same denominator, BD. Going straight across here, AD divided by BC, and straight across the bottom, BD divided by BD. Well, we're just dividing by 1, so we've got that same answer in the numerator, A times D, and in the denominator, B times C. Same as what we saw up here. So that's not a commonly used method. We don't usually think of needing a common denominator or the least common denominator for dividing of fractions, but because we're getting the same answer, and along with the fact that I didn't choose any particular fractions, I was writing a general proof there. That means that the second method will always work.